Good morning students. Today we'll be dealing with the combination section under the concepts of principles of counting. So let us see the definition of combination. Before we tell the definition of combination, I'll just go back to the definition of the permutations. So we were considered an example of ABC, and we found the permutation of this term. So if you use the permutation formula, you remember n factorial divided by n minus r whole factorial. So here all three possible arrangements of this would be 3 factorial divided by 3 minus 3 factorial. So that was 3 factorial. So we got 6. So the possible arrangements of ABC were ABC, ACB, as well as BAC, BCA. Then you had CAB and CBA. So these were the 4 possible outcomes. I mean 6 arrangements we got it for the combination, permutations when we did it over there. Over there arrangement was important, like ABC was arranged in ACB, again BAC, BCA, CAB, CBA. Now when it comes in the case of combinations, it is just a selection. We are not worried regarding the ordering of the objects. So it is just ABC. If you want all 3 to be arranged, then the result is only one choice, ABC itself. But in the permutation, if you give A, B, C, what are the number of permutations for all 3 objects, then it would be 6. Whereas in combination, it is we are interested in choosing a set of R objects from a set of N objects without regard to order. I don't want anything regarding the order. I'm just worried regarding the selection. So if I use the formula for the combination is n factorial divided by n minus r whole factorial r factorial. So if you do this particular formula, then it would be 3 factorial divided by 3 minus 3 whole factorial into 3 factorial. So you know that 3 minus 3 factorial is 0 factorial, that is 1, and 3 and 3 will get cancelled. The answer is 1. So this is the only possible result for the combination when it is ABC. Now let us go back to the one more example. Permutation of ABC taking 2 at a time. Taking 2 at a time. That means what? N is 3. R is 2. So the permutation formula is n factorial divided by n minus r whole factorial. So it was 3 factorial divided by 3 minus 2 is again 1 factorial itself. So it was nothing but answer was 6. So ABC, out of this taking 2 at a time, it would be nothing but AB, BA, BC, CB, and AC would be CA. So these were the possible outcomes we got for the permutation. Okay, now let us see for the combination taking 2 at a time. Let us apply the formula. It is again n factorial divided by n minus r whole factorial into r factorial. So it is nothing but combination formula is permutation of n comma r divided by r factorial. So permutation is this itself. So into r factorial. So over here it will be n is 3, r is 2, because we are taking out of this 3 I am arranging 2. I'm selecting 2 at a time. So it is 3 minus 2 is 1 factorial. Here r is 3 minus 2 is 1 factorial, and r will be 2 factorial. So it is 1 factorial and 2 factorial. Answer is 3. Why 3 into 2 factorial and this 2 gets cancelled? Answer is 3. Over here if you see AB and BA, right, out of this one AB is chosen, BC is chosen, AC is chosen. When you take 2 at a time, so choosing is AB, BC, AC. All these are nothing but the different selections. All these are nothing but the different selections. So now let us see the definition. Suppose we are interested in choosing a set of R objects. So here let us take 2 out of ABC. I took 2 objects from a set of n greater than or equal to R objects. So obviously n is 3 over here. 3 should be always greater than or equal to, this n should be always greater than or equal to r without regard to order. There is no constraint of order. Whereas in permutation, we were worried regarding the order. It is a combination where the order was important. Where the order doesn't matter is nothing but the combination. So the set of R objects being selected is called a combination of R objects. The total number of combination of r different objects that can be selected from different objects is equal to this formula, p of n comma r divided by r factorial. So this is denoted by combination of n comma r, and the formula is combination of n comma r, and the formula is this, where condition is there where n is greater than or equal to r. In case if you have r greater than n, then c of n comma r is always equal to 0. Why? Because just see over here, n is 3 and r is equal to 4. I don't have next term to be chosen itself, then the result will be always equal to 0. Other than this, you need to remember the few definitions of the combination. So that is c of n comma n, and c of n comma 0 is always equal to 1. That is, for example, you take n is equal to 5 comma 5 and 5 comma 0 and try to solve, we'll get 1 itself. If you see over here, we got 3 and 3 arrangements. See, this was c of 3 comma 3, we got the result as 1. Also when it is 3 comma 0 also we'll get it as 1. And other than this, c comma n comma 1 and c comma n minus 1 is also equal to n. So these 4, if you remember, it will be easy when solving the problems. You can directly substitute because since you have the formula. So c of n comma 1 is n, c of n comma n minus 1 is also n. So this is regarding the definition of the combination as well as regarding the formulas used in the combination. So let us start with the example problems. The example 1 is, how many committees of 5 with a given chairperson can be selected from 12 persons? So you have to form a committee of 5. How many committees of 5? 1, 2, 3, 4, 5 with a given chairperson. That means out of this committee 5 members, one should be a chairperson, can be selected from 12 persons. So totally there are 12 persons. One place can be occupied by chairperson. Remaining should be a normal person. So out of this, how many committees of 5 can be formed with the given chairperson? So in this 5 itself, one is a chairperson, can be selected from 12 persons. So how can I choose one particular chairperson? It can be from 12 persons, right? So out of that 12, how many chairpersons I need to choose? 1. So 12C1 for chairperson, that means one chairperson I'm choosing from 12 person. Since it is happening simultaneously, remaining should be a normal person of a committee members. That means a committee person. One is a chairperson, remaining is a committee members. So how many left out place is there? So it is 4. 1, 2, 3, 4 selection should be there. Out of how many members? Since one person is already occupied, for example, out of this 12, one is already taken as a chairperson in this. So remaining is 11 members. So it is 11C4. So it is 11C4. So 12C1 into 11C4 is nothing but the answer of this particular question. So that is, how many committee of 5 with a given chairperson can be selected from 12 persons. So the solution is, the chairperson can be chosen in, write down the solution, the chairperson can be chosen in 12 ways. Okay, that is nothing but 12C1, and other 4 on the committee can be chosen, and other 4 on the committee can be chosen in 11C4 ways. Therefore, the possible number of such committees, therefore the number of possible committees, therefore the number of possible committees is equal to 12C1 into 11C4. So the answer would be, if you try to solve, you need to solve over here. 12C1, as I told, NC1, it is always n itself, so it is 12. Try to solve this formula, that is 11 factorial divided by 11 minus 4 factorial into 4 factorial. So this would give you the answer 3960. So this is the answer for example 1. I'll just repeat how many committees of 5 with a given chairperson they have told. So 5 members, in that one should be a chairperson. So that one chairperson I can choose is from 12. So it is choosing 12C1 into 1 is already occupied. So left out is 11 people. In that I have to choose 1 is occupied for the chair. So out of that 11, 1 is gone for chair. Remaining committee members have to choose. So totally 4 places is left. So it is 11C4. So this is regarding the example 1. So this is regarding the example 1. Example 2, find the number of committees of 5. Find the number of committees of 5 that can be selected from 7 men and 5 women. Okay, find the number of committees of 5 that can be selected from 7 men and 5 women of the committee. Is to consist of at least one woman. Is to consist of at least 1 woman and 1 man. Okay, there is a change in the question. Is to consist of at least 1 woman and at least 1 man. Okay, and at least 1 man and at least 1 man. So here the question is, find the number of committees of 5. Find the number of committees of 5 that can be selected from 7 men and 5 women of the committee. 7 men and 5 women of the committee is to consist of at least 1 woman and at least 1 man. At least 1 woman and at least 1 woman. So at least means what? Minimum there should be 1 woman, and at least 1 man means 1 man means minimum 1 man should be there. 1 man should be there. So this is regarding the question. So here there is a continuation of the question, at least 1 man. Okay, till here the question is at least 1 woman and 1 man. Continuation of the question. So here find the number of committees of 5. Again the committees we have to form is 5, 1, 2, 3, 4, 5. So totally there are 7 men and 5 women. 7 men and 5 women. So this problem we can solve in 2 ways. I'll mention both the ways, and in that they have given the condition that is to consist of at least 1 man and 1 woman. So if you tell 1 man and 1 woman, see the possibility for the men is I can have at least 1 man means least 1 man, or else I can have least 1 man, then 2, 3, 4. Why I cannot have 5? Because there is a constraint that 1 woman also should be there. So if I take 1 woman over here, one possibility is I can have 1 man, then I can have 2 men, 3 men and 4 men, because 1 is occupied by women. So one way is I'm choosing 1 man, then 2 men, 3 men, 4 men. Similarly for women also I should choose 1 woman, 2 women, 3 women, 4 women, and 1 place should be given for man itself. So this is the meaning. Least you can have 1 man, max you can have 4 men. Least you can have 1 woman, max you can have 4 women. So what are the possible ways I can do this particular problem? That is nothing but there are totally how many men's? We have 7 men's over there. So you can choose 4 men's. I told 4 max you can choose 4 men's. So if you choose out of 7 4 men's, then one place is left out. If you choose 4 men, 1 place is left out. So that is 5C1. So this is one way. Second way, you can choose 3 men, 7C3, and 2 you can give it for women. And next is again 7C3 you can give 2 for women, and then again over here 7C4 is done. 7C2 I can choose 2 men and I can choose 3 women, and then next at least 7C1, and here I can have 5C4. So this is the possible way you can do it, and finally add these ways. So in one committee I will get this many numbers, here I'll get these many numbers, here finally add this particular number. So this is one way which I can solve. So that is, I'll write it again here. So one is I am choosing one condition is I am choosing 4 men and 1 woman. So that means 4 men 1 woman means it is 7C4 into 5C1. Okay, next I can choose 3 men and 2 women. 3 men and 2 men. So it is again 7C3 into 5C2. Next I can choose 2 men and 3 women. So it is again 7C2 into 5C3. Next I can choose 1 man and 4 women. So it is again 7C1 into 5C4. So over here if you see, 4 plus 1 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. All the constraints is matched. See, max men you can have is 4. So you had max 4. Next max is 3. Next max is 2. Next is minimum is 1. If you see in the constraint of women also, max you can have 4, 3, 2, 1. All the condition is been matched. So try to solve this and find the answer of this. So you'll get it around, I think, when it is 7C4 and into 5C1, it is actually 7 factorial. I'll just write here 7 factorial divided by 7 minus 4 is 3 factorial, 4 factorial into 5C1 is 5. So here you will get the answer as 7 into 6, 7 into 5. I think you'll get it as 35. You will get it as 35. This you'll get it as 35. 35 into 5, you'll get it as 175. You'll get it as 1. So this, if you solve, it is 7 into 6 into 5 into 4. 7 into 6 into 5 factorial. 4 and 4 gets cancelled. So 3 factorial this and this. So 35 into 5 is nothing but 35 into 5, you will get it as 175. So 175 is the answer over here. And in this 7C3 and 5C2, 7C3 and 5C2, you will get it as, the answer is 7 factorial. I'll just solve here. So it is 7 factorial divided by 7 minus 3 is 4 factorial into 3 factorial into 5 factorial divided by 3 factorial into 2 factorial. So here 7 into 6 into 5 into 4 will get cancelled. So I think it is 7 5s are 35. 7 5s are 35, as well as 7 into 6 into 5 into 4 factorial divided by again 4 factorial. So this and this gets cancelled. Here 3 factorial is there, this and this cancel. So 35. This result will be 35, and here it is 5 divided by 5 into 4 into 3 factorial. You keep 3 and 3. So this and this gets cancelled. 3 and 3 gets cancelled, and then again it is then again it is 5 into 4 divided by 2. So it is 2, and here 2 it is 10. So it is 5 2s are 10. 10 into 35, you'll get it as 350. So this answer is 350 over here. And here 7C2 as well as 5C3, you'll get it as 7C2 and 5C3, will get it as 210. You can cross verify. And 7C1 into 5C4, you know that 7C1 is 7 itself, and 5C4 is based on the formula itself, NC n-1, NC n-1 and NC n, you will get it as n itself. So here it is 7 into 5, it is 35. Finally add all these sums. So it will be 175 plus 350 plus 210 plus 35. So that is equal to 770 number of ways. So this is one way you can solve this particular problem. So this is one way you can solve the problem. One way. And other way you can do it is, the other way in the textbook what they have done is find the number of committees of 5 that can be selected from 7 men and 5 women. 7 men and 5 women is nothing but total is 12. Okay, 12. 7 plus 5 is 12. 7 plus 5 is 12. Find the number of committees of 5 that can be selected from 7 men and 5 women of the committee is to contain at least 1 woman and 1 man is our question. So what they have done is, from the total combination, that is 12, okay, from this they have subtracted from the given 12%, the number of committees of 5 that can be formed is this one. Among these committees, there are completely condition, we are breaking the constraint, at least 1 woman is there, right? We are subtracting the combination of all possibilities of 5 women. and at least one man is there, right? We are finding the combination of 7, 5. So if you solve this answer also, you'll get it as 792 for this, as well as minus of 5, 5, you know, n, n is always 1, so you'll get it as 1, and for 7, 5, you'll get it as 21, so again you'll get 770. So if you want to explain me this in both the problems, I'll just tell. So here the question is, find the number of committees of 5 that can be selected from 7 men and 5 women. Of the committees is to consist of at least 1 woman and 1 man. So first what I did is total combination of these committees. So the total combination is, I have to find committee of 5, then total people are 12. So this 12C5 will give me what? Formation of committee including both women and men, including both women, total committee of 5 that has to be formed. From this I am subtracting all the combination of women, from this I am subtracting all the combination of women and all the combination of men. So that will give me what? Exactly the count of at least one woman, max 4 women. So this is same. I did what? C of 5, 5. I subtracted the combination where it comes all women's of committee is been formed. That means 5 is also placed with women. 5 is also placed with women, that I subtracted. So we had 5 women, 5, 5. That is the combination. And again committee of 5 members with including 5 men itself. So 7, 5. So this will give me the result what? Excluding from the total, excluding all women and excluding all men. So that is what is the constraint. At least 1 man means max 1 man and 1 woman means 1 man. Once you can take it as 1 man, next you can take it as 2 men, 3 men and 4 men. And max what you can have? When it comes to 5 men, constraint breaks. So 1 woman is mandatory. So when it comes to 5 men, constraint breaks. So that is what? You subtract that constraint. So same way when it comes to women also same. 1 woman, 2 women, 3 women and 4 women. When it comes to 5 women, it breaks. So this is the constraint. So this is regarding the example 2. Either you can solve it in this way or you can solve it in this way. Whichever way you are familiar, you can solve it. So 4 women and 1 woman is one choice. 1 woman, 3 men, 2 women, 2 men, 3 women, 1 woman, 1 man and 4 women. So this is regarding the example 2. Next, example 3. At a certain college, the housing office has decided to appoint for each floor 1 male and 1 female residential advisor. So at a certain college, the housing office has decided to appoint for each floor 1 male and 1 female residential each floor 1 male and 1 female for the resident. How many different pairs of advisor? Pair of advisor means obviously male and female should be used. Can be selected for 7 floors. So there are totally 7 floors. 1, 2, 3, 4, 5, 6 and 7. Totally 7 floors. Okay. For this 7 floors also we want pair of these. All the 7 floors I need. Okay, so how many different pairs of advisors can be selected for 7 floor building? From 12 male and 15 female candidates. So what you have to do is I need for all the floors. So I need 7 females, right, for 7 floors. So out of 15 I need to choose 15C7. Out of 12 males, again how many floors I need men? Simultaneously it's pair. So pair 12C7. So 12C7 into 15C7 is the answer. 12C7 into 15C7 is the answer. So we can just write from 12 male candidates. From 12 male candidates, from 12 male candidates, 7 male candidates can be chosen. Can be selected in C of 12,7 ways. Why 12,7 ways? We have 12 males and out of that we are going to arrange 7. Okay, and then females, and then from 15 females, 7 female candidates can be selected, right? So from 15 females, 7 female candidates can be selected. can be selected. So it is in can be selected in C of 15,7 ways. Since it is happening simultaneously, see, housing office has decided a point for each floor, one male and one female, and is there simultaneously, one male and one male. So it is product rule. So it is what happening simultaneously. So therefore the total number of possible ways, therefore the total number of possible ways, possible pairs of advisors is equal to C of 12,7 into C of 15,7. So the continuation I'll write over here. The answer is nothing but 12 factorial divided by 7 factorial. That is 12 minus yeah, this is 12C7, right? So 5 factorial into 12 minus 7 is 5 factorial into r factorial is 7 into 15 factorial. 15 minus 7 is again 8 factorial 8 factorial into 7 factorial. So this will give the answer as 792 into 6435, that is equal to 5096520. So this is the answer for the example 3. Example 4. A certain question paper consists of two parts A and B. A certain question paper consists of two parts A and B, each containing 4 questions. So you have a question paper A as well as B. Here each consists of 4 questions. A certain question paper consists of two parts A and B, each containing 4 questions. How many ways a student can answer 5 questions by selecting at least 2 questions from each part? So you have a set of question paper where part A consists of 4 questions, part B consists of 4 questions. That is what, and he is telling that a student can answer 5 questions. Okay, he can answer 5 questions by selecting at least 2 questions from each part. Minimum 2, max he can select is 3. Minimum he can choose 2, max he can choose is 3. So here the solution, see, minimum at one possibility is he can choose from the section A 2 question and from the section B 3 question. Okay, one possibility, because questions he can answer is 5. How many ways a student can answer 5 questions by selecting at least 2 questions from each part? So if he has taken 2 questions from A, then he should answer 3 questions from B. In case if he has taken 2 questions from B, then he should answer 3 questions from here. So there are 2 possible ways. Either you can choose 2 from this and 3 from B, 3 from this and 2 from this. Finally, find the combination and find the combination over here. Add those combinations, you'll get the answer. So the first way is the different ways. First is nothing but the different ways a student can select is 5 questions are, first criteria is he can choose 2 questions from A, because 5 has to be answered, right? So he can choose 2 questions from our part A, 2 questions from part A and 3 questions from part B. So this can be done in, in 4C2, because you have 4 questions in A, choosing 2. Simultaneously he has to answer, right? So it is a product rule. So he has mentioned, see, 2 parts and A and B. How many students can, by selecting at least 2 questions from each part? So while you write an examination, you will do simultaneously, right? So 4C2, that is if you're choosing 2 questions from A, so 3 mandatory you're going to choose, 3 mandatorily you're going to choose from where? From B. So B also has this combination. So this will give you the answer as 4C2 if you do 4 factorial divided by 4 minus 2 is 2 factorial, r is also 2 factorial. Here it is 4 minus 3 is 1 factorial, then 4 minus 3 is 1 factorial, then again 3 factorial. So this will give you the result as 24 ways. 24 ways, because here 4 will be there and here 4 into 3 into 2. So again you will get it as 24. If you solve, you will get it as 24. Second possibility is 3 questions from A, 3 questions from part A and 2 questions from part B, and 2 questions from part B. So this can be done in 4C3, 3 questions from part A, 4C3 and 4C2. So again same, 4 factorial divided by 4 minus 3 is 1 factorial into 3 factorial. Again 4 factorial divided by 2 factorial, 4 minus 2 is 2 factorial into 2 factorial. So this will also give you 24 ways. So these are the 2 possibilities, right? Like 2 different sets when you write. So therefore the total number of ways, I'll write over here. Therefore the total number of ways a student can answer five questions under given restriction is equal to 24 plus 24, so that is equal to 48 ways. 48 ways. So this is regarding the example. So the next problem is regarding example 5. So in the example 5, there is a question paper contains 3 parts, A, B, C, with 4 questions in part A. In the part A question you have 4, 5 questions in part B and 6 questions in part C. So it is required to answer 7 questions. 7 questions a student should answer, 7 questions, selecting at least 2 questions from each part. So from each part he has to choose 2. That means if you choose 2, then max he can choose is 3, because if you constraint is 2 and 6 questions is done, 1 more question you have to choose. So in each part he has to choose minimum 2, and in one part it might be possibilities 3. So for example, if he chooses 3 from part A, remaining should be 2 from this, and in case if we choose 2 from here, B section it will be 3 and here it will be 2. In case if we choose 2 and here 3. So these are the 3 possible ways a student can choose a particular question from each part. So a certain question, I'll repeat the question, a certain question paper contains 3 parts A, B, C, with 4 questions in part A and 5 questions in part B and 6 questions in part C. 6 questions in part C. Okay, and it is required to answer 7 questions. It is required to answer 7 questions, selecting at least 2 questions from each part. Least 2, max it can be 3, because to maintain the constraint, that is restricted is only 7 questions, right? So max he can choose 3, least is 2. So in how many different ways can a student select these 7 questions for answering? So the first possible way is 3 questions from part A, 3 questions from part A, 2 from part B, 2 from part C. So this is one possible way. 3 questions from part A, 3 questions from part A, 2 from part B and 2 from part C. So the possible will be C of 4, 3 into, that is 4 is from A section as 4, C of 5, 2 and into C of 6, 2. C has 6 options, so 6, 2. So this is the first way. So the answer you'll get over here is 4 into 10 into 15. So you'll get 600 ways. This is regarding the first section. In the second section, I can choose 2 from part A and 3 from part B and 2 from part C. 2 from part A, 3 from part B and 2 from part C, second section. So that can be done in, so just write over here 2 questions from part A, 3 from part B, 2 from part C. So this will be again 2 questions, means it will be 4C2 since A has 4 questions, and 3 means 5C3, and then 6C2. So this will be actually 6 into 10 into 15. While you solve, you'll get 6 into 10 into 15. So that is 900 ways. So this is second possibility. Third possibility, I'll just write over here. Third possibility is 2 questions from part A, 2 questions from part A and 2 from part B. Write in statement itself, I'm just writing over here 2 from part B and 3 from part C. 3 questions from part C. You write it in terms of statement over here. So the answer will be 4C2 into 5C2 into 6C3. So the answer would be 6 into 10 into 20. So you'll get it as 1200 ways. Finally, the total number of ways you have to write, the total number of possible. So the continuation I'll write over here. Total number of ways. Therefore, the total number of ways is equal to, first part what you got the answer is 600, second part you got 900, and next you got 1200. So the total sum would be 2700 ways. So this is the possible number of ways. You can choose the example, you can choose the certain question paper where a student attempts 7 questions with all these 3 conditions, restrictions. Is it clear with this example 5? Next, let us go to the example 6. So in the example 6, a woman has 7 close relatives, 11 close relatives, and she wishes to invite 5 of them to dinner. So she has 11 relatives, but she wishes to invite only 5. Okay, in how many ways can she invite them in the following situation? So there are 11 relatives and she want to wish 5 of them with these 3 following situation. Okay, there is no restriction on the choice. When there is no restrictions on the choice, she can choose any 5 relatives out of 11. So for this, solution is nothing but 11C5. Okay, when there is no, since there is no restriction of the choice of invitees, 5 out of 11 can be invited. So here you can write the statement as first one. Since there is no restriction, on the choice, she can invite any 5. She can invite any 5 out of them. She can invite any 5 out of 11 members. Okay, she can invite any 5 out of 11 members. So that will be equal to 11C5, and the solution would be 11 factorial divided by 11 minus 5 is 6 factorial into 5 factorial. That would give you 462 ways. So this is regarding the first. Since there is no restriction on the choice, she has 11 close relatives and she wishes to invite 5 of them to dinner. These were the 3 situations. In the first, she did not have any restriction. Next, second situation is 2 particular person will not attend separately. That means what? Out of those 11, right? 11. 2 particular person will not attend separately, means they will attend either together. Separately means they will not attend separately, means that means they will attend the dinner or any function togetherly. So out of that 11 members, they will attend the dinner togetherly. So either them, see, out of those 11, 2 people, okay, consider 11 means 2 people, that is 11 minus 2 is remaining is 9. 2 people will attend the party togetherly, meaning is that Two people will attend the party togetherly, will not attend separately. That means they should attend togetherly, and two should not attend the party itself. Either they should attend together or either they should not attend the party itself. So that is the meaning of this second statement. Either they should attend the party togetherly or they should not attend the party togetherly. So second solution will be since two particular person will not attend separately, since two particular person will not attend party separately, they should both be invited. They should both be invited or not invited. They both should be invited or not invited. Then three more invitees are to be selected from the remaining. So if they, first case is they both should be invited. If in these two cases, right, either they both should be invited. If both, in this second one, sub question I'll write A. Both, if both invited, out of that 5 invitees, right, 5. So consider A and B, both are invited. So left out is 3 places. Okay, left out is 3 places and both are invited. So from 11 subtract 2, left out is 9 members, and how many seats are there? 9C3. So if both are invited, number of possible ways 9C3. So that is nothing but 9 factorial divided by 9 minus 3 is 6 factorial to 3 factorial. So this will give you 84 ways. Why this 9? Because both are invited. I fixed, let them be AB. I fixed their positions. Both are invited. So 11 minus 2 is 9 and 2 places is occupied. Left out is 3. So it is 9C3. Now B is if both are not invited. If both are not invited. If both are not invited, then all 5 locations are there. All 5 locations needs to be there because both are not invited. So what should be done? 11 minus 2 because I'm not inviting them. So 9C5 because both are not invited. So those cannot occupy these places. So 5 arrangements should be there and they should be subtracted from the total. So it is 9C5. So it would be 9 factorial divided by 4 factorial into 5 factorial. So this would result in 126 ways. 126 ways. So 126 ways. So therefore the total number of ways in which the invitees can be selected. Therefore the total number of ways in which the invitees can be selected is 84 plus 126 is equal to 210. 84 plus 126 is equal to 210. So the total number of ways is equal to 84 plus 126 is equal to 210. So for this you got answer as 210. Next, two particular persons will not attend together. Meaning is there are 2 persons. If one person comes, one person doesn't come. If other person comes, the other person does not come. So that is since 2 persons. So that condition I'll mention. I'll do it in a new page. Okay. Question is 2 particular person will not attend togetherly. Third one is 2 particular person will not attend together. So for this the answer is will not attend together. For this the possible way is when the tell will not attend together, let those 2 particular persons be we had total how many persons? We had 11 relatives. We had to choose 5 in that 11 relatives. Let me write over here. We had total persons 11. Out of that 5 should be invited, right? So 11 persons, 5 need to 2 particular person will not attend togetherly. since two particular persons, say P1 and P1, will not attend togetherly, since P1, P2, let P1 and P2 will not attend togetherly, since P1, let it persons be P1, P2, will not attend togetherly, then only one of them needs to be invited or both should not be invited. So for example, possible three conditions we have. If P1 is invited, P2 is not called. If P1 is invited, out of this 5 position P1 is occupied and 1, 2, 3, 4 is left out. So here below possible is 4 ways, 4 I have to choose because 1 is occupied. So 11 minus this P1, 11 minus P1 is 1, 10 I got. Plus if this P1 attends, P2 will not come. So it is 11 minus 2, totally 11 minus 2, so it is 9. So here 1 is already occupied, so remaining was 10. 11 out of 11, 1 person occupied, 10. But if P1 attend, P2 will not attend, so it is 9C4 number of ways. 9C4 ways. So that is 9 factorial divided by 9 minus 5 is 4 factorial, sorry 5 factorial into 4 factorial. So this will give you 126 ways. Similarly, second sub question is if P2 attends, if P2 is invited. If P2 is invited, P1 will not attend. So here it will be P2, one position, 1, 2, 3, 4 is left out. 4 positions is left out. So it is C4 over here. Here P2 is invited. So 11 minus 1 position is occupied. So 10. If this person attend, P1 will not attend. So it is 9C4 again. So it is 9 factorial divided by 9 minus 4 is 5 factorial into 4 factorial. So this also will give you 126 ways. And we have the third constraint. Two particular persons will not attend togetherly. There might be a situation that if both P1 and P2 are not invited, if both P1, P2 and P1 are not invited, if both are not invited, then 11 minus 2 people. So it will be 9. If both, write the statement over here. If both P1 and P2 are not invited, if both P1 and P2 are not invited, then the number of ways of choosing is 9C5. So that is also again it would be 9 factorial divided by 9 minus 5 is 4 factorial in 5 factorial. So 9 factorial, again it gives 126 ways. Therefore the total number of ways is 126 plus 126 plus 126. So it would give the answer as 378 ways. 378 ways. So this is regarding the example 6. Let us go to the example 7. So it is slightly different, where actually the permutation concept is also being involved over here. From 7 consonants and 5 vowels. So you know, other than the vowels, whatever is there, it is a consonants itself. So they have told there are 7 consonants and 5 vowels. You know, vowels can be only 5. Okay, vowels can be only 5. So that vowels, you know, A, E, I, O, U. So these are the vowels. From 7 consonants and 5 vowels. How many sets consisting of 4 different consonants and 3 different vowels can be formed? Here if they are told 4 consonants and 3 vowels can be formed, then it would be directly like 7C4, because 4 different consonants. Out of 7 I want to form 4 consonants and 3 different vowels, like into, and it is there 5C3. This would be the answer. If they are told directly from 7 consonants and 5 vowels, how many sets consisting of 4 consonants and 3 vowels can be formed? In case if they are told 4 consonants and 3 vowels can be formed. Here they are told, since they are told different consonants, 4 different consonants and 3 different vowels. That's why we need to consider 4 consonants and 3 needs. They need to be arranged, right? So again, within them these consonants needs to be arranged. So for example, you have choose those 3 that needs to be arranged over there. For that we are multiplying into a 7 factorial, because we need total 4 different consonants and 3 different vowels. This 4 and 7 needs to be arranged. So that's why we need into 7 factorial. So I'll just write the statement over here. The 4 different consonants can be selected. The 4 different consonants can be selected in C 7,4 ways, different ways, and 3 different ovals can be formed in combination of 5,3 ways. Okay, combination of 5,3 ways, and the resulting 7 different letters can be arranged themselves, and the resulting whatever that letter, right? Since they are told different, how the different consonants can be formed, that's why we are multiplying. We need to consider the arrangement among themselves. So we will just write, and the resulting 7 different result, and the resulting 7 different letters that is within the bracket 4 consonants and 3 ovals can be arranged themselves, in 7 factorial ways. Therefore, answer is nothing but 7C4. This is of consonants 7. Out of that 4 you are choosing. Out of 5 ovals you are choosing 3, and into 7 factorial. So this would give you 7 factorial divided by 7 minus 4 is 3 factorial into 4 factorial into 5 factorial divided by 5 minus 3 is 2 factorial into 3 factorial into 7 factorial. So this would be 35 into 10 into 5040. Answer is 5040. Answer is 1764000 ways. Okay, since they have told why the concept of permutation came, since they have told how many sets consisting of 4 different consonants and 3 different ovals, if they are not told regarding the word different, then the permutation wouldn't come out there. Since they have told the use different over there, that's why the concept of permutation came. So this is the only one problem actually which is a bit tricky, because we are involving the concept of permutation. So this is regarding the example 4. Thank you.